Hello everyone. Today we'll see pair of linear equations in two variables activity. Aim of this activity is to obtain conditions for consistency of a pair of linear equations in two variables practically. Try to understand the meaning of consistency. It means that when the pair of linear equations have at least one solution, it means that those pairs are consistent. That we'll find out practically with doing the graph on the graph paper. Here, for this activity, we need to have some prerequisite knowledge. That means how to plot the points on the graph paper and how to draw the line through them, as shown in the graph paper here. Right? Now, materials required here. First, we'll need graph papers. We'll need 3 graph papers and ruler, pencil, and rubber. So be ready with this. Here, given 3 pair of linear equations. See the first one here. X minus 2y equal to 5 and 2x minus 4y equal to 6. This is the first pair of linear equations. Now look at the second one. X minus y plus 1 equal to 0 and 3x plus 2y minus 12 equal to 0. And here is the third one. X plus 2y equal to 5 and 3x plus 6y equal to 15. So for these 3 pair of linear equations, we'll draw the graph, and then from the graph, we'll do the observation whether the lines are consistent or not. Procedure 1. Consider the first pair of linear equations. Look at the first equation here. This is the first equation. As we have first equation, we need to find out solutions for this equation. So see the solutions here. Now see here, when I am taking value of x as 3, I get value of y as minus 1, right? So here for our convenience, I have written y which is equal to x minus 5 by 2. How did I get it? See what I did, this plus 5, I brought it this side, it became minus. So x minus 5 and this minus 2y, I brought it to the right hand side. So 2 which was multiplying here, it went that side to divide, correct? So in this way, I got y which is equal to x minus 5 by 2. And here when you substitute 3 minus 5, it means that minus 2. Minus 2 by 2 is minus 1. Here second value of x is 5. So 5 minus 5, it is 0. 0 by 2 is 0, correct? Same way the third solution. So here always remember, you will take the smaller integers, not the bigger one, so that they should fit on the graph paper. Only this is the reason. Let us see the second equation. Now for the second equation also, we'll find out 3 solutions. Look at this one here. I have written the equation y which is equal to. Even if directly you will substitute the value, no problem here. But if you write down the equation either y equal to or x equal to, that is more convenient. Okay. See here, if I take the value of x which is equal to 1, so I get value of y which is equal to minus 1. Same for the second solution and the third solution. Once I get 3 solutions, now I need the graph paper. See here, this is the graph paper. Now look at the x-axis here and y-axis, correct? Now we need to draw the first point. Now look at this one here, first point, 3 comma minus 1. 3 on the x-axis and minus 1 on the y-axis. So our first point should come here at this place. Now look at the second point from the first table, 5 comma 0. 5 on the x-axis and 0 on the y-axis. It means that point is on the x-axis here at this place. And the third point, 7 comma 1. See here, 7 on the x-axis and 1 on the y-axis. So third point is at this place. Now we have plotted the points. We need to draw the line through them. So look at this line here. We got the line for the first equation. Now move towards the second table here. In the second table, the first solution is 1 and minus 1 here. 1 on the x-axis and minus 1 on the y-axis. So here the first point will come. Second point, 3 comma 0 here. Third point, 5 comma 1 at this place. And then we will draw the line through them. Once we draw the line, we need to write down equations on them. So look at here. This is the equation of the blue line and this is the equation of the red line. After that, one more important thing is that we need to write down the scale. See here, scale on the x-axis is 1 division, which is equal to 1 unit. How you will get it here? Take any two consecutive numbers. Suppose this 2 and 1. From the bigger number, you subtract the smaller number. And whatever the answer will come, that one will be the scale on the x-axis. So here 2 minus 1 is 1. That's the reason I have written here 1 division equal to 1 unit. Same for the y-axis here. Correct? Now, after doing this one, what is the observation? Look at the graph. Look at those lines. What do you feel? Which type of lines these are? Correct? Aren't they parallel? Right? So these lines are parallel. This is our first observation. See here, the lines are parallel. This is the first observation. Now, you just look at the equations of these two lines. First equation and second equation. And look at their coefficients. So, coefficient of this x is a1 and coefficient of this x is a2. So, a1 by a2, if I write down, I get 1 by 2. Now, same here. This is b1. Coefficient of y is b1 and coefficient of this y is b2. So, minus 2 by minus 4 is once again 1 by 2. And this constants are c1 and c2. So, it is 5 by 6. See here, a1 by a2, 1 by 2, b1 by b2, 1 by 2, and c1 by c2, 5 by 6. First two ratios are same and third one is not same. Correct? So, whenever this one will be the condition, that means lines are parallel. As the lines are parallel, they are not sharing any solution, no common solution. If the solution is not there, no common solution is there, it means that lines are not consistent. So what we'll call them? Lines are inconsistent. So practically we are showing lines are inconsistent. Correct? Come to the second procedure. Consider the second pair of linear equations. Look at the first equation here. Look at the solutions. Correct? Here, once again I have written y which is equal to x plus 1. What I did, this minus y I have sent to the right hand side. So I got the equation y which is equal to x plus 1. So when x equal to 0, y equal to 1. When x equal to 1, y equal to 2. This way I got 3 solutions. Come to the second equation. Now for the second equation also, we'll write down 3 solutions. See here. Now here once again I have written y which is equal to 12 minus 3x by 2. And here when you substitute x equal to 0, 12 by 2 is 6. X equal to 4, that means 12 minus 12 is 0. 0 by 2 is 0. Right? And here same for this one. So we get 2 and 3 as the solution. So once you get the solutions, once again we'll need the graph paper. Here we plot all these points here. Look at the first table. First point is 0, 1. It means that the point is on the y-axis here. Second point 1, 2. 1 on the x-axis, 2 on the y-axis. So see here, second point will come at this place. Third point is minus 1, 0. So point is on the x-axis. So at this place. And then we draw the line. Right? Come to the second table here. First point is 0, 6. So 0, 6 point is on the y-axis here. Second point is 4, 0. Point is on the x-axis here. And third point is 2, 3. 2, 3, it means that point is here. So after drawing this one, once again we'll draw the line. Correct? We have completed drawing the lines. Now what is needed? We need to write down the equation of the lines on the graph paper here. See, equation for the blue line, equation for the red line. After that, the important work is that we have to write down the scale. Look at the scale, same scale as the previous one. Correct? On the x-axis, 1 division equal to 1 unit. On the y-axis, 1 division equal to 1 unit. Now, you will observe the lines, how these lines are, right? They are intersecting lines. So our first observation is what? The lines are intersecting lines. Second observation, what you will do? You will look at these equations of the lines. See? And the ratio, right? A1 by A2, B1 by B2, and C1 by C2. See here? Ratios are A1 by A2 is 1 by 3, B1 by B2 is minus 1 by 2, and C1 by C2 is minus 1 by 12. First two ratios are not equal. As soon as you see first two ratios are not equal, that means lines are intersecting. As these lines are intersecting, they have only one common solution. See, only one common solution they have here, right? So that means at least one solution is there. It means that these lines are consistent lines, right? So we are once again showing the lines are consistent because they have a single solution for the intersecting lines, right? Come to the third procedure. Consider the third pair of linear equations here. See the first equation. We'll write down the solutions for the first equation. Here see, x equal to 5 I have taken. I got here 5 minus 5 by 2. That means 0 by 2. I get y equal to 0. Same way, I got the second solution. I got the third solution. Right? Come to the second equation. For the second equation also, I have found 3 solutions. Right? Just look at this one. Here, x equal to 5. So I get y which is equal to 0. So here 3 5 are 15. 15 minus 15 is 0. 0 by 6 is 0. Second is 3. Once again 15 minus 3 into 3 is 9. 15 minus 9. Right? So here 6 by 6 is 1. So the third one. Right? So we got the 3 solutions for each equation here. Once again the graph paper. Here we'll plot the points now. 5, 0, that means point is on the x-axis at this place. Second is 3, 1. Here, 3, 1. Third is 1, 2. 1, 2. And then we have drawn the line through these 3 points. Now we write down the equation on the line. Now, for the second line also you see, look at the points. 5, 0. So here, once again at the same place, 1 point I got. Second point is 3, 1 here. Third point is 1, 2 here. And then we have drawn the line through these 3 points. Correct? Now, in this case, always try to take the small values, and that also in the form of integers. If you will take integers, you will find it more convenient. Okay, you can take any value, no problem at all. But try to take the integers. That is more convenient for us. Now here, once again, we'll write down the equation of the red line also. What do you observe here? Just see. Both the lines are overlapping lines. That means each and every point they are sharing. Each and every point is common. Correct? So first, let me write down the scale here and then the observation. Lines are coincident. Coincident, that means they are overlapping lines. Same line. Correct? Coincident lines. Now think about the ratio here. Ratio of the coefficients. All the ratios, as you observe, are equal. If all the ratios are equal, it means that lines are coincident and those lines have infinitely many solutions. Why infinitely many solutions? Because each and every point is common for both the lines, each and every point. And on the line, there are infinitely many points. That's the reason both the lines are having infinitely many solutions. Therefore, lines are consistent. Right? I said at least one solution, then also lines are consistent. But these are many solutions. That means definitely both the lines are consistent lines. Right? Now here, We need to write down the conclusion now. Look at the first analyzation table. Here, I have written both the pair of linear equations here. Lines are parallel. Now look at the ratio here. First ratio, second ratio, and third ratio. What we observe here from the ratio. First two ratios are equal, third one is not equal. That means if this is the condition about the pair of linear equations, definitely lines are parallel and they are inconsistent. Correct? Because they don't have any solution. Come to the second one. Your second pair of linear equations, lines are intersecting. Already we have seen them. Already we have written these ratios also. What we observe, first two ratios are not equal, right? For the intersecting lines. Come to the third one, third pair of linear equations. Lines are coincident lines. All the ratios are equal. Look at the condition here. All the ratios are equal. So what is our observation? Our observation is lines are parallel. This is the condition for the lines. Lines are intersecting. This is the condition for the intersecting lines. And lines are coincident. This is the condition for the coincident lines. This is the observation, right? Now come towards the another analyzation table. See here. If the lines are parallel, no solution. And if no solution is there, that means lines are inconsistent. Correct? This only we wanted to see through the graph. Correct? Here, lines are intersecting. That means only one solution. And lines are consistent. Coincident lines, then infinitely many solutions. And lines are consistent. Correct? So all these observations we have done from the graph paper about the pair of linear equations. Now it's your turn. Try this analyzation table. Look at this one here. First pair of linear equation. I have written here first two ratios which are not equal. If this ratio is not equal, which type of lines these are? That you are going to write down. These lines have only one solution. That means lines are consistent or not. That you have to decide. Come to the second pair of linear equations. Now you will write down the ratio here on your own. These lines are parallel lines. For the parallel lines, how many solutions are there? That you will write. And these parallel lines are inconsistent. Come to the third pair of linear equations. Write down the ratio. Write down the type of lines. These lines have infinitely many solutions and lines are consistent, right? If you are having confusion, just see once again the same video, you will come to know. Thanks for watching. See you in the next video.